So in this example today, we're going to be going over implicit differentiation, and a lot of people ask when it's used. It's used to compute dy of dx when x and y are related. The first step is to take the derivative of both sides of the equation with respect to x. The second step is to solve for y prime by collecting the terms involving y prime on one side and the remaining terms on the other side of the equation. So what we want to do is just solve for y prime. We're going to take the derivative of the whole function and solve for y prime. And that's pretty much what we're going to do. So let's just go ahead. And this is our first example. It's x squared times y plus 2x y squared is equal to x squared plus y. Let's just give ourselves some room. So dy dx x squared times y plus 2x y squared is equal to x plus y. Well, we see we have to use the product rule on these two functions because it's two functions being multiplied. So remember, it's first times the derivative of the second plus the second times the derivative of the first. Then we're going to do that again for this one. So it's first times the derivative of the second plus the second times the derivative of the first. And then the derivative of x is 1, the derivative of y. And implicit differentiation is y prime because you follow, when you take the derivative of y in implicit differentiation, you follow it with the y prime. So now we got x squared y prime plus 2xy plus 4xy y prime plus 2y squared. This is all equal to 1 plus y prime. So now we're just going to use our steps that I said in the beginning, is just to put all the y primes on one side and all the other terms that don't have y primes on the other side. So x squared y prime plus 4xy y prime minus y prime is equal to 1 minus 2xy minus 2y squared. So now we see that we got a y prime in all of these. So now let's just factor that out. X squared plus, so it's y prime times x squared plus 4xy minus 1, which is equal to 1 minus 2xy minus 2y squared. So then just to solve for y prime, you just move this to the other side by dividing. So y prime is equal to 1 minus 2xy minus 2y squared, all of this over x squared plus 4xy minus 1. And that should be your final answer. Let's just see here and make sure. And that is your final answer. So we found dy of dx by, remember, we found dy of dx by taking the derivative of the whole function, taking the derivative of both sides of the function, following every derivative of y with y prime. So right here we took the derivative of y, so that's y prime. Took the derivative of y right here, so that's y prime. And took the derivative right here, and that was y prime. And followed it with y prime, I should say. that isn't y prime. We just followed the derivative of this with y prime. And then what we did is we moved all the y primes on one side and moved all the other terms that don't have y primes on the other side. And pretty much we did that because, as you can see, we just wanted to factor it out. Pretty much. Or that's what we wanted to do. We wanted to factor it out. And then once we factored it out, we could just easily solve for y prime just by moving it on the other side, and we get our final answer. So we'll do one or two more examples here. So let's do 3y cubed plus x squared equals 5. So let's just do what we know how to do. We find the derivative with respect to x of the whole equation. 3y cubed plus x squared is equal to 5. So this is going to equal 3 times 3y squared times y prime plus 2x is equal to 0. And I just moved the 3 out in front here, multiplied it by 3y squared, and then followed the derivative of every y with y prime. And right here I just used the power rule, just moved the 2 out in front, minus by 1, and we got 2x. And the derivative of any constant is just 0. So now we're left with 9y squared y prime plus 2x is equal to 0. And now we do what we know what to do. We move all the terms that have y primes, which is this, to one side, and all the other terms to the opposite side of that, of the equal sign. So now we're going to get 9y squared y prime is equal to negative 2x. Then we're going to go y prime is equal to negative 2x all over 9y squared. That is your final answer. So what we did is we took the derivative of the whole function, moved our terms that don't involve y prime on the other side of the equal sign of the terms that do have y primes, and then we just solved for y prime after that. So we'll do one more example. So we'll do x squared times y plus y to the 4th minus 3x equals 8. And we just we want to find the derivative of y with respect to x of this whole function. So we write it like that with that notation. So we're going to have to use the product rule right here, and then just the power rule and the power rule. So remember, it's first times the derivative of the second plus the second times the derivative of the first, then all of this plus 4y cubed y prime minus 3 is equal to 8. Not 8, it's equal to 0. So we followed every y with y prime and we took the derivative of x. That's the point of implicit differentiation. Remember, y prime is equal to dy of dx, which is what we want. So now we get all the terms that have y primes on one side, and all the terms that don't have y primes on the other side. So let's just do that right now. So it's going to be x squared y prime plus 4y cubed y prime is equal to 3 minus 2xy. We move the 3 by adding, we move the 2xy by subtracting. So that's how we got 3 minus 2xy. And then we factor out the y prime. So x squared plus 4y cubed is equal to 3 minus 2xy. And then we just solve for y prime. So y prime is equal to 3 minus 2xy all over x squared plus 4y cubed. And that is your final answer. Let's just check and verify here. And that is the right answer. Because that's what my solution manual says. So pretty much it's what I said. You take the derivative of the whole function with respect to x and follow every y with the y prime. Because you want to find the derivative of y. So you follow it with every y with y prime. And then we just simplified it here. Moved all the terms on this side that involve y prime, that have y primes in their equation, that have y primes. And then we moved all the things that don't have y primes over on the other side of that. And so that makes it real easy just factoring out y primes out of these and then just solving for it. Then we solved for it after that. Then we got y prime, which is what we wanted at the beginning. We wanted dy of dx.